Alright, so Tess has a picture that measures 18 inches by 2 feet. So let's draw this picture real quick. Okay, so 18 inches by 2 feet. She wants to add a frame around the picture that has a width of 3 inches. So this is 3 inches. What will be the total square footage needed on the wall to hang the picture? Okay, so it's just asking for, whoops, on the wall, what's all this area that the picture and the frame will cover? Okay, so you know the bottom piece was 24, and these are like, they have like swimming pool problems where they have like the cement or whatnot border around the cement, or sorry, around the swimming pool. So you have 3 on each. So anyone, please tell me what would the total be of this one? 30. Because it'd be 24 plus 2 groups of 3. So it'd be 30 inches. Okay, and just like we did the groups of 3 on the left and right, we have to do the groups of 3 on the top and bottom. So what would that be? 24. So you could just do 24 times 3, add the 0. Okay, so what? 2170. So 720 what? Inches squared. Is that correct? You all agree? Oh, nice catch. Okay, square footage. So this is incorrect. Nice catch, because it's not in feet. Okay. So let's convert the original ones back to feet. So 2 feet and 30 is 2.5. You with me? So if I multiply these, what do I have? 5 what? Square feet. Now, how could I change this? This is actually a good question. Thanks for asking, and thanks for catching the mistake, because we're going to show you something on the calculator as well. Okay, so how could I change? Let's say that I realized, ooh, I have it in inches squared. Could I do some kind of conversion factor and get it to feet squared? Well, how do I do that? So inches squared, okay, is in the numerator right now, right? We would have to put it on the bottom, and what would the ratio be to get from feet squared to inches squared? Don't be shy. What goes on top? Just 1, and then what goes on bottom? Say again? 144. Because it's not going to be just the linear thing. This is very similar, pun intended, to similarity ratios. Remember that? So similarity ratios, we're not just doing 1 over 12, which is one-dimensional. We're doing 1 over 12 squared, which is 144, which is two-dimensional. You with me? So in our calculators, let me go ahead and sign in just real quick. Alright, so in our calculator, 1 for new document, no to unsaved changes. Let's go ahead and add a calculator page. We're going to do the conversion factor. If we go back to our notes, as far as, or the problem, we are doing 720 over 144. And you get 5. Is that correct? Okay, so 5 square feet. So yes, you can change it here. If you remember similarity ratios with the base squared or volume base cubed, right? Or you can go back to here. I think a lot of people might go here and play it safe and then just solve out the area. Okay? Now, let's go to the calculator. Make sure that we know that the calculator can also do this and we can use it to our advantage. Okay? So let's go to 720 inches squared in our calculators. So 720 underscore inches squared. And then we're going to do what? Do y'all remember what buttons for the conversion factor? Yeah, control book. Control book. And go to that triangle And then underscore, we're going to change this to what? Feet squared. And there you go. 5 feet squared.
I did the fraction thing.
You don't need to do the well, you can if you want, but I think those are more so for like velocities. You know what I mean? When you have rates of change. This is not a rate of change. These are one-dimensional positions. Questions? All right. Nice.